Doppler effect is widely used and observed, from measuring the rate and direction of blood flow to checking for speeding violations to discovering that the universe is expanding. Have you ever wondered why the pitch of the sirens of an ambulance increases then drops as it drives past you? The answer is in the Doppler effect. What is the Doppler effect? It is the change in frequency of a wave observed by an observer due to the relative movement between the observer and the source of the wave. In this example, the ambulance is the source of the sound and the pedestrian is observer A. When both the source and the observer are in stationary positions, a diagram like this can be drawn, where the sound waves travel away from the source in the directions indicated by the arrows, and the concentric circles are the wavefronts, which represent all the points in the waves that are in phase. The wavelength of the sound waves from stationary source is given by the equation lambda equal to v over f, where v is the speed of sound in air and f is the frequency of the sound waves. Now the source moves to the right towards the observer at a speed of vs. As a result, the wavelength of the sound waves traveling in the same direction is shortened. The new wavelength of the sound waves, denoted by lambda prime, is equal to the speed of sound minus the speed at which the source is traveling towards the observer, divided by the frequency of the sound waves. Due to this change in wavelength, the frequency measured by the observer, denoted by f prime, is f prime equals to v over lambda prime. When we substitute lambda prime with the equation for lambda prime that we've previously looked at, we derive this equation for f prime. This is the equation that represents the Doppler effect for an approaching source. When the source moves in the opposite direction away from the observer, the wavelength increases instead and the opposite effect to that described before takes place. Because a high-pitched sound corresponds to a high-frequency sound wave and a low-pitched sound to a low-frequency sound wave, the pitch of the sirens of an ambulance changes with the changing observed frequency.